Okay, so I'm going to be doing problem 32. To start, we're just going to read 31 because it gives some context on it. So a baseball diamond has the shape of a square with sides 90 feet long. A player running from second base to third base at a speed of 25 feet per second is 20 feet from third base. At what rate is the player's distance S from home plate changing? So that gives the context for it. We're talking about a player who's running the bases. You can see the baseball diamond right there. Moving to 32, the question that we're going to be answering is for the baseball diamond in exercise 31. Suppose the player is running from first to second at a speed of 25 feet per second. Find the rate at which the distance from home plate is changing when the player is 20 feet from second base. So to start off, we're just going to draw a little baseball diamond. Not perfect, but we're going to call that second, first, home, and we're just dealing with second and first and home in this. So we have right angles all around there. So it is a square. And then in 31, we are told that the sides are 90 feet long. So I'm just going to go ahead and label one of these. And we know that right now the player is, so for our knowns, I'm just going to go ahead and label these sides X and Y. We know that the player is running from first to second right here at a speed of 25 feet per second. So that means that dy dt equals 25 feet per second. And then we know that we're finding the rate at which the distance from home plate is changing when the player is 20 feet from second base. So if the player is 20 feet from second base, that means he's right here. And if we know that this whole thing is 90 and this right here is 20, then we're going to go ahead and use this distance right here to figure it out. So then 90 minus 20 is going to be 70. So our y is going to equal 70 feet. And then we know that our x is going to equal 90 feet because we were told that in our first one. So then what we're trying to find is his distance, how the distance from him to home plate is changing. So we're going to use that point. So from here to here is our y, and from here to here is our x. And then this is going to be our, let's call it a z value. So what we're trying to find, our unknown, is our dz dt. So how fast is that? And we know that it's a right triangle, so we're going to use Pythagorean theorem to solve that. So then that's going to have z squared equals x squared plus y squared. And then we can derive that to get our dz dt, but first we're going to need to know our z value. So our z is going to equal the square root of x squared plus y squared. So that, mathing that out on a calculator, is going to equal, we know our our x is 90, so 90 squared plus 70 squared, and then take the square root of that. And that's that. So I'll keep this exact value in my calculator, but we'll just say for now that it's that. Okay, so then we know our z value. So now we're going to go ahead and we're going to derive our this equation right here, our Pythagorean theorem. So to derive that, we're going to get 2z dz dt equals 2x dx dt plus 2y dy dt. So then we're going to fill in what we know already. We can cross out the 2's because it's on every single component of the equation, so then they're just going to cancel out anyway. So we know that's our z value. So I'm just going to write it as z until we fill it on our calculator. Z dz dt equals, and then we have x, which is 90, but our x value is not changing at all because it's a solid length and he's not running that side. So our dx dt is actually going to be 0. And then plus our y, which is 70, times our dy dt, which we know is 25 feet per second. So then that gives us z dz dt equals 70 times 25, and 70 times 25 is 1750. So then we're going to divide both sides by z, which I have stored in my calculator. So we're going to divide iz, which is this. And then that gets us our dz dt, which equals 15.349. It says doesn't give us a round for this, so we're just going to leave it at that. And then we know that it's changing at a rate of feet per second. So that leaves dz dt equaling 15.349 feet per second. And that is the rate at which the distance from home plate is changing when the player is 20 feet from second base. So we can write that on a sentence. So we can say, when the player is 20 feet from second base, his distance from home plate is increasing at a rate of 15.349 feet per second. Okay, that is how you do that problem.